Okay, let's go over the sample test for chapter 7, tangent of negative 15. And I want an exact value. So we're going to have to use special angles somehow. Now, if we could double negative 15, actually, if we could double it, we'd have 30. And we can do special angles of 30 or negative 30. And there's a tangent of an x over 2 equals several things. It's either the square root of, that would be the sine one, which is 1 minus cosine x over 1 plus cosine x, or it's sine x over 1 plus cosine x, or it was 1 minus cosine x over sine x. Any one of those formulas. They should all give me the same answer. So if x divided by 2 is negative 15, then x must be negative 30. So I can put negative 30 in here, and I would get the cosine of negative 30 is square root of 3 over 2. And the sine is negative 1/2. So I'd get the square root of 1 minus square root of 3 over 2 over 1 plus the square root of 3 over 2. I could work that out, or I could work out the sine, which is negative 1/2 divided by 1 plus the square root of 3 over 2. Or I could do 1 minus the square root of 3 over 2 over minus 1/2. And they all should come out to be the same answer. Let's kind of check that. So the square root of parenthesis 1 minus the square root of 3 divided by 2, close parenthesis for the numerator, divided by open parenthesis 1 plus the square root of 3 divided by 2, and we get that answer. Now, here we don't know whether it's plus or minus. Tangent of negative 15 would be in the fourth quadrant, and so it should be negative. So that would be one exact answer. Another exact answer should be this one. I'm going to check and see if it comes out to be the same decimal. Negative 0.5 divided by parenthesis 1 plus the square root of 3 divided by 2. And now we get the negative answer. And this one, let's see what that comes out to be. Parenthesis 1 minus the square root of 3 divided by 2, that's the numerator, divided by negative 0.5, and we also get the negative 0.2647. So those give us an answer. Those are all the same. We could also get it by doing, using the tangent of a difference. Tangent of alpha minus beta, or alpha plus beta. We might use a sum or difference. I think I'm going to use a difference because I can get 15 by doing like 45 minus 30, or 60 minus 45, or a bunch of different ones. And so this becomes the tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta was our formula. So if I make this be, say, 45 and this be 30, I'd get plus 15. So I'd want to do 30 and 45 minus 30 minus 45, and I would get minus 15. So I would do tangent of 30 minus tangent of 45 in degrees over 1 plus tangent 30 tangent 45 multiplied. Let's see. Now, just to check our answers here, tangent of 30 is 1/2 over the square root of 3 over 2, so that's 1 over the square root of 3, minus tangent of 45 is 1, because the sine and cosine are the same, over 1 plus tangent of 30 again, tangent of 45. And that should be the same answer, that negative 0.2679. That's an approximate answer. I want an exact answer. So let's try parenthesis 1 divided by the square root of 3. Nope, don't put the parenthesis there. That minus 1 is the numerator, divided by, open parenthesis, 1 plus 1 divided by the square root of 3. And hopefully we get the same answer. And we do. So this would be an answer. This was an answer. This was an answer. This was an answer. Those are just some of the ways to get the answer for that one. There's multiple ways to do that one. Okay. Cosine is negative 5/13 in either quadrant 1 or quadrant 2, somewhere between 0 and pi, and it's negative, so it has to be over here, negative 5/13, and the hypotenuse is 1, so we got to get that one, which is 25/169 cosine squared plus sine. Wait a minute, I should be looking at this one. I'm doing this one now. So I'm finding the sine of theta squared equals 1. I'm doing B accidentally. Skipped A here, so I'll have to go back. So I'm going to take this from that, and 1 is 169 over 169. So I got to take 25/169 from 169 to 169. So that makes 144 over 169 is sine squared theta. So I take the square root, and the sine of theta can be either plus or minus 12/13. But since we had to be here, the sign is positive. Let's go back and do this one that I skipped. So the sign is positive 4/5, somewhere between here and pi. So here, the sign is 4/5. And the hypotenuse is 1. So that's 16/25 plus cosine phi squared is 1 squared. So I subtract 16/25 from 25/25, and I get cosine squared phi is 9/25. So cosine of phi is the square root of that, which is either 3/5 or negative 3/5. But if it's there, the cosine is negative. So there's the cosine, there's the sine. If I have to do the cosine of the two angles added, that's the cosine of the first, cosine of the second, minus sine of the first, sine of the second. Cosine of the first is negative 3/5. Cosine of the second was negative 5/13 minus sine of the first is 4/5. Sine of the second is 12/13. So our common denominator is 5 times 13, and we got 15 of those minus 48 of those, which is minus 33. 5 times 13 is 65. Sine of 2 theta is 2 sine of the angle times the cosine of the angle. So it's 2 times sine of theta is 12/13. So you can see that if you don't get these right, you're going to miss a whole lot of problems. And the cosine of theta was negative 5. So we got 10 times 12, 120, negative over 169. And from problem 1, there's 2 or 3 answers for this. I'll just use, say, the first one, sine of x over 1 plus cosine x. Using the half angle formula. And the sine of phi is 4/5 over 1 plus cosine of phi was negative 3/5. So 4 over 5. 5/5 minus 3/5 is 2/5. Multiply numerator and denominator by 5, and I get 4 over 2, which is 2. Page 2. If I have sine of an angle, cosine of an angle, different angle, minus cosine of the original angle and sine of the second angle, that's the sine of two angles subtracted. That's the sine of alpha minus beta. So this would be the alpha, and this the beta, and so this becomes the sine of 122 minus 31, and that is 91. And I wanted an exact answer, so I have to stop there. I can't go to decimal approximation. Now, if this had happened to be 90, I'd expect you to do the sine of 90, which is 1. This is close to 1, but not 1. Okay. Well, from sine squared x plus cosine squared x equal 1, you can divide everything by cosine squared, and you get, if we divide sine squared by cosine squared, we get tangent squared. Dividing by cosine squared on here, we get plus 1. Dividing by cosine squared here, we get 1 over cosine squared, which is secant squared x. So you could put this in for the secant squared. You could subtract 1 over to here and put secant squared x minus 1 in for the tangent. Or you could say subtract the tangent over and say secant squared minus tangent squared is 1. You use any one of those three substitutions and you should get this part to equal 1. And then minus cosine squared x. And 1 minus cosine squared is sine squared x. 1 minus the cosine squared is sine squared. Maybe I should show you doing one other one. Let's say we put tangent squared x plus 1 in for the secant squared. So we get tangent plus 1 minus tangent squared x minus, and these cancel. Excuse me, I'm battling a cold. So we get 1 minus cosine squared, which is sine squared. Okay, let's go to the next one. So we got a sine to the fourth. So going sine squared minus 1 is the negative of cosine squared. 1 minus sine squared is cosine squared. So we could call this negative cosine squared because that's the negative of that, and that's the negative of that. So we could call it cosine squared squared. The cosine to the fourth is another one that equals this. But we want to get sine to the fourth in our answer. So instead of changing this to cosine squared, let's go ahead and square this quantity by going sine squared x minus 1 times itself. That's what squaring it means. This times this is sine to the fourth x. This times this would be minus sine squared x. And this times this is another one, so that'd be minus 2 of those. And that times that is plus 1. So we've got the sine to the fourth of x. We got that. And this, if you look at your identities for the cosine of 2x, 1 minus 2 sine squared x is a cosine of 2x from our list of things. So this becomes sine to the fourth x plus cosine 2x. All right, let's do this one. Single x is here, so I'm probably going to use double angle formulas to reduce this down. Now, cosine 2x has 3 of them. 2 cosine squared x minus 1, 1 minus sine squared x, and cosine squared x minus sine squared x. Those are all cosine 2x. There's no plus 1 here. If I use this one, the 1 would cancel that 1. So I'm going to go ahead and use this one for the cosine of 2x. I'm going to go 1 plus 2 cosine squared x minus 1. This part is the cosine of 2x. Sine of 2x is 2 sine x cosine x minus cosine x. Now, if the ones cancel, I'm really close to getting that. I just need one of the cosines to disappear. Now I notice that in this, there's a cosine in both of these. So I could factor that out. So I'm going to get 2 cosine squared x over 2 sine x minus 1 times the cosine x. Cosine x times this makes that. Cosine x times minus 1 makes that. So then this cosine that's times everything can cancel one of these, and I get 2 cosine x over 2 sine x minus 1. Okay. And finally, the back page. A pendulum is pulled to the left 20 centimeters. So it's fastened to the ceiling or something there. So it's hanging out here and let go at time 0. So it's going to go over to here, then over to here, back and forth, and slowly slow down. And if this is long enough, it can take as long as 5 seconds, 1001, 1002, 1003, 1004, 1005, to make a complete swing right and back. Each period is decreased by each period the amplitude is decreased by 1%. So the amplitude is what's in front of the function, and since we're starting not from the center line but off of it, I'm going to use the cosine. So its position is going to be, and that's negative. Normally, if I make it to the left, that's normally negative. So I'm going to just write negative, and it's pulled over 20. So it's going 20 off the center. Cosine, and its period is 5 seconds, so it's 2 pi divided by 5 t, where t is in seconds. This would be good if it just kept going and never slowed down, but it says that it loses 1% each period. So what's left is 99%. And that's per period, and the period is 5 seconds, so I got to put t over 5. So when I put 5 in here, 5 seconds, it'll do 99% of 20, making it a reduced amplitude. So there's the function. What time will the pendulum swing never more than 1 centimeter from the center? Well, that means when is the amplitude 1 or less? And this is the amplitude, so negative 20 times 0.99 to the t over 5 equals 1. So I divide by negative 20 or 20, doesn't matter. And then to solve for a power, we do logs. So to what power do we take 0.99 to get negative 1/20? Well, we can't do a negative for logs, so we're going to just do 1/20th. And that can be done on a calculator. You can either do change a base rule. Oh, and that's equal to t over 5. So I'm going to have to take this answer times 5. So the change of base rule is log, using the log button, of the 1/20th divided by log of 0.99. and take that answer times 5, and I get 1,490 seconds. I could change that to minutes and find out how many minutes it takes it to die. Now, there's also a log with a different base under math. Log in a different base. The base is 0.99 of 1 divided by 20, and then times 5, and I get the same answer. Excuse me. Now, if you try to put in negative 1/20th, see what happens here. I think it's going to complain because you can't. It gives you I, which is not valid. But you can see it's trying to give a real part that is a number and an imaginary part to get the negative. If you ignored that and took that times 5, you'd get the same answer, because that's what we had before. Okay? Logs generally don't do it of negative numbers. Okay. What is the position of the pendulum after 1 minute? That means we just got to go up here and put 60 in. So it's going to be minus 20 times 0.99 to the 60 divided by 5, which is 12, cosine 60 divided by 5 is 12 times 2 is 24 pi. Cosine of 24 pi is 1, because that's an even number of times all the way around the circle, even number of pi, so I end up here. Cosine is 1, so it's just going to be negative 20.99 to the 12. It'll be at negative 17.727 centimeters. Since it's negative, it's to the left.